Alright, question one. Perimeter of a square that has 10 millimeters as its sides. And if you know anything about a square, all the sides would be equal. I've just drawn these little lines, and you'll see these a lot on diagrams to indicate that all the sides are in fact equal. So if every side is 10, we could just do 10 plus 10 plus 10 plus 10. We could also do 10 times 4. Either way, your answer is going to be perimeter of 40 millimeters. Alright, we need the perimeter of this triangle, or this rectangle. To understand what we're actually doing here, you just have to follow the description of the rectangle. Before we even read it, you know that a rectangle has two longer sides and two shorter sides. The two longer sides are the same length, as indicated by these two lines. The shorter sides are also the same length as indicated by the one line. We know that the long side is 20. So for the other sides, we should be able to pick them out by this phrase. One side twice as big as another. So this would be our one that's the biggest side. So we know this is twice as big as the short side, meaning that this is going to be 10. This would also be 10. And then we would have 20 right here. Now we just have to add up all the sides. 20 and 20 is 40, 50, and 60. For this rectangle, we have a perimeter of 60. This question ends up being pretty straightforward. We have all the sides of this triangle, we just need the perimeter of it. So all we have to do is add up all the sides. I've just indicated here with one line and one line that these two are the same, and two lines, this one is different as far as side length goes. So 5 and 5 is 10, add the other side would be 16. So our answer is going to be a perimeter of 16 inches around the outside of this triangle. Alright, perimeter of a regular hexagon. So we've got to figure out what regular and hexagon would be. Regular just means all the sides are going to be equal. Okay, so we got that. Hexagon means it has 6 sides. So we got 1, 2, 3, 4, 5, 6 sides. The sides of the regular hexagon, since they're all the same, it says the sides are 8. So we should be able to assume that since it's a regular hexagon, all the sides are going to be 8. So now we can simply count by 8s if you would like to do it that way. Or since we have 6 8s, basically is what we're saying, we have 6 sides that are all 8, we can just do 8 times 6, and 8 times 6 is going to be 48. So our perimeter of this regular hexagon is going to be 48. Now here's a diagram laying out the situation. For you to get to school, you've got to walk 6 blocks east, and you've got to walk 8 blocks north. So that's a grand total of 14 blocks to get to school. I want to know basically what that equivalent would be in blocks if you were to just take this northeast path that goes straight from home to school. As you can tell with this diagram, we have formed a right triangle. Our two things and then our path make a triangle, and we've got a right angle in it, so it's a right triangle. Things we need to identify before we use our Pythagorean theorem to solve this. We know that the path in this case is our hypotenuse. It's the one that's opposite of the right angle, or the slanted side. Okay? We always use the hypotenuse as C. The other two, it doesn't matter. We could call them 1A and 1B. They're just the legs. It doesn't matter. So I'll just go with this as an A and this is a B. So now we just need to use our formula to fill in the blanks here. Okay? A, if we call it 6, is going to be right here. So that's going to be 6 to the second power. B to the second power is going to be 8 to the second power. We'll eventually add those together. And then that's going to equal C to the second power, which we know the number we're going to get here is already to the second power. So to get the opposite of this, we're going to eventually have to do the square root of it. So 6 to the second power is going to be 36. 8 to the second power is going to be 64. Add those together, and I believe you get 100. Now, remember, this number is already to the second power. And if you can't remember that, you should just be able to look at the numbers and say, well, if it's if this line is 6 and this line is 8, there's no way this line is going to be 100. That doesn't make any sense. So we have to reverse this second power right here by doing the square root. 100 to the second power is just 10. So our trip from home to school is basically 10 blocks. If you wanted to know how much we were saving, these two together would be 14 blocks. So altogether we are going to save a trip of 4 blocks. So the distance of our straight path is 10 blocks. We're saving 4 blocks is basically what we're doing there. A lot of things on the board here for question 6, but it's all pretty easy. What I like to do on these perimeter, circumference, radius, diameter, circle problems is draw out one of these charts because I think it helps me organize my information. Things you're going to have to know here, we talked about the symbol for pi, and we're just going to use 3 for it. Okay, and our formulas to find circumference are just pi times diameter, which is just 3 times diameter. To be honest, you really don't need a formula for this. We've talked about at length that the distance across the circle, so if we have our circle here and we know that the diameter is 10, the distance across the circle, 3 of these equals the distance around the circle. We've talked about that a lot, so you shouldn't really need a formula for it, but here it is just in case you need it. And remember, if these two things are right beside each other, it's just like multiplication. But I'm just going to use the theory that 3 diameters are going to be the distance around the outside. Remember, the circumference is the distance around the outside. It's the fancy word for perimeter of a circle. So I know that this is going to be 30. 3 of these is going to be 30. If I used my formula, it would just be pi is 3, 3 times whatever my diameter is, 3 times 10, and 3 times 10 is 30. Okay. Don't need a formula for radius. If we know the diameter is 10, the radius is half that much, halfway across the circle. So halfway of 10 is just going to be 5. So in this case, our radius is going to be 5. Two radii is going to be a diameter, which will be 10. And then it takes 3 diameters to make the distance around the outside. So 3 tens is going to be 30. So radius is 5, circumference is 30. Alright, first of all, let's get this out of the way. That's the best goat drawing I can do right there. So it doesn't even look like a goat. It looks more like a cat. But since I put goat on there, then we're going to call it a goat anyway. This problem is not really that difficult, but it's more picking out what the problem is actually talking about. So I'm going to make my chart over here because I think it's easy that way. We know that the goat is tied to a stake and the rope is 30 feet long. Now, and we're trying to figure out how far of a circle around this thing it could walk. So if we drew this diagram, that 30 feet, that's the radius. That's going to be halfway across the circle that it could walk around. Okay, so we should be able to fill in the diameter pretty easily. The diameter is just going to be twice as big as the radius because the diameter is all the way across. So if the diameter is all the way across, that's going to be 60. And we talked about our formula for circumference. Circumference is pi times diameter, which is the same thing as 3 times diameter. So in this case, pi would be 3 times our diameter of 60. 3 times 60 is going to be 180 feet. So the goat has a circumference to walk around of 180 feet. Now, even easier, we know that the distance across the circle, which in this case would be 60 feet, we know we can fit 3 of those into the perimeter of the circle, or into the circumference. So we could just simply take 60, 60, and 60. We need 3 of these. 60, 60, and 60 is 180. So this goat has a path of 180 feet to walk around its stake that it's tied to.